friends, how are you all? Welcome to Coding Sahai. I am Reshma R. So we were discussing the programs using for loop and while loop. So part 1 and part 2 videos are uploaded already. So those who haven't watched, please go and watch. The links are mentioned in the description box. So in this video, we are going to discuss more programs using loops, mainly while loop. Okay, so let's begin. So before we start, if you are new to my channel, please do subscribe to my channel and share the videos. So let's begin. So our next program is write a program to check the given number is prime or not. So what is a prime number? So you know prime number is a number which can be divisible by that number and 1. That is our prime number. Other numbers are not prime numbers, isn't it? Let me write the program and after that I will explain it. Prime number. So as usual, I'm giving num for a change. Int, enter the number. I'm giving a counter c equal to 0. Then we can give the loop again for I in range of 1, num plus 1. Now let me write like this. If num modulo I equal to 0, that is I am checking the divisibility check. If it is divisible, then I am giving c equal to c plus 1. Then outside my loop, if c equal to 2, then we can print num is prime, else print num is not prime. Let's save the program and run it, and after that I'll explain the logic. Okay, it's asking enter the number, so I'm giving 11. So it is printing 11 as prime. Let me enter another number. So I'm giving 132. Here 132 is not prime. Okay, so our program is working properly. So let me explain the logic here. Num equal to, so when I entered 11, num is equal to 11. So we have a counter here c equal to 0. Then for I in range of 1, num plus 1. So here the limit is from 1 to 11. That means 1 and 11 included. Actually 1 to 12. So 1 to 11 it is working. So here first, if num modulo I equal to 0, that is what is num? It is 11. 11 modulo I. What is the value of I? The value of I is actually 1. So num modulo 1 equal to 0. Yes. So our counter is incrementing by 1, that is c equal to 1 now. Now again it is going back, and for I in range of 1, num plus 1, that is I equal to 2 now. Then again checking 11 modulo 2 equal to 0. Is it satisfying? No, it is not satisfying. So c equal to c plus 1, it will not be executed. So it's going back, and I equal to 3 now. Then again checking 11 modulo 3 equal to 0. Is it satisfying? No, it is not satisfying. Then I equal to 4. Then 11 modulo 4 equal to 0. Not satisfying. So it executes till I equal to 11. So here 11 modulo 11 equal to 0. Is it satisfying? Yes, 11 divided by 11, we get the remainder as 0. Our counter, it was 1, c equal to 1. Now it is incrementing by 1, that is 1 plus 1, you get the value 2. Okay, c equal to 2. Now I is incrementing, that is 12, but it is not in that range, so it comes out of the loop. And after our loop, we have the statement if c equal to 2. The value of c is 2. That means it is checking whether 2 equal to 2. Yes, it is satisfying. So it is printing num is prime. Otherwise, it is printing num is not prime. Okay. So why I have given if c equal to 2? See, if you take any number, there are two factors for that number. One is that number itself and 1. Okay. So here, you know, if it is a prime number or not a prime number, obviously 1 and that number will be there. So here actually we have taken the number 11. So we have 1 and 11. If it is a prime number, then there is only two factors. What are the factors? That number and 1, isn't it? So that's why I have given if counter equal to 2, then it is a prime number. So any other number you take, suppose if you are taking 25, you know 25, it is actually 5 is there, then we have 1 and 25. So it will be more than 2 factors, isn't it? This is the logic for prime or not. Then let me ask you one question. What about 1? Whether 1 is a prime number or a composite number? 1 is neither prime nor composite. Whether I have given any code for that. If the user is inputting 1, then we have to give a message. 1 is neither prime nor composite. Okay, so how can we make changes in our program? So we can make change as here if num equal to 1, then we can print the message print num is neither prime nor composite. Else only we have to do this operations. Okay, now I have given it properly. Let's check it. Okay, entering the number 1. So it is printing 1 is neither prime nor composite. Okay, I'm giving 13. 13 is prime. 36. 36 is not prime. This is a program to check whether a given number is prime or not. So let's do the next program. So our next program is write a program to find the sum of digits of a number. Suppose if you are taking a number like 1, 2, 3, 4. Okay, so here actually our digits are 1 plus 2 plus 3 plus 4, 10. This is our sum of digits of a number, right? So the number will be entered by the user. So any number will be entered by the user. So here, you need to extract each digit, that is unit place, then the tens place. So all the digits you need to extract. So how can we extract it? See, in one of the previous videos, in one program, I explained how to extract the unit place, right? That is, if you are doing modulo operation with 10, then you will get the unit place. That is, you can extract this 4. That is, you can check it here. 1, 2, 3, 4 divided by 10. If you do, then 1 tens are 10. Then 23, 2 tens are 20. Then 34, 3 tens are 30. And 4 minus 0, you will get the remainder 4. When you are doing modulo operation with 10, then you get the unit place value. So how will you get this 3? So if you are doing modulo operation with 123 and 10, you will get 3. So how will you get this 123 from this 1, 2, 3, 4? So for that we can write 1, 2, 3, 4 floor division 10. So you will get the answer as 123. See, what is floor division? Here we are doing the division with 10, but the decimal part will be ignored or truncated. So here 1, 2, 3, 4 floor division 10, if you do, then you will get the answer 123. Then again this 123 modulo 10, if you do, you will get the answer as 3. Then again 123 floor division 10, you will get 12. Then 12 modulo 10 is 2. So like this we can do the operation. So here it is repeating, that is modulo operation, then floor division. Modulo operation, floor division. So it is repeating. So in this case we can use while loop. Okay, so here we have a condition till where we need to do this operation. That is, we are doing floor division, that is our update statement here. So whenever this value, for example, if it is n, then n becomes 0, that time we can come out of the loop. So like that we can write the code. So let me write the program and after that I'll explain it. So the command sum of digits of a number. As usual, we need to input a value. So int input enter a number. So what is our next operation? We need to extract the digits and that digits we need to add it there, right? So whatever the digits you are extracting, you are adding with the previous extracted one. So if there is no previous one, then we need to add it with 0. So we know some of the series when we did, we initialize s equal to 0. So here also we can initialize a variable like this. What is next? We can start our while loop. So here I am giving while n not equal to 0, or we can say n greater than 0. So n not equal to 0, then we need to extract it. So for extraction I am giving r equal to n modulo 10 I am giving. Then what is next? You extracted it, now you need to add it. So we can write S is equal to S plus R. So what's our next operation? Next operation is we need to reduce our number. If it is 1, 2, 3, 4, then we have to make it as 1, 2, 3. How can we do that? We can do floor division. So here I am writing n equal to n floor division 10. Okay, now what's our next operation? We need to print the sum. So we can write print sum of digits. It is an S. So let's save the program and run it. So for the example, we used 1, 2, 3, 4. I am giving that. So it's giving sum of digits equal to 10. It's correct. 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. See here, we have entered 1, 2, 3, 4 and sum of digits is 10. It is giving. Suppose if you want to make a small change in your output, like sum of the digits of 1, 2, 3, 4 is 10. Like that, if you want to print it, then how can we make a change? See here, which variable has that value? 1, 2, 3, 4. Here n has that value, right? After doing this operation, n becomes 0. That time only it is coming out of the loop. So we cannot write sum of digits of n is S because n prints 0. So we can do one thing. See here, I am using a temporary variable t which is equal to n. That is, I am storing the value of n in t. Then here I can give sum of digits of t is. So I changed it as sum of digits of t is S. The original n value is there in t. Okay, so let's save it and run it. 321 I entered. Now see, sum of digits of 321 is 6. So let's see the logic of this program. So I have entered the number 1, 2, 3, 4, n. So then we have t equal to n. That means t equal to 1, 2, 3. Then we have S equal to 0. So S is initialized as 0. Then we are checking whether n not equal to 0. What is n? It is 123. So 123 not equal to 0. It is satisfying. Okay. Then it is coming inside our loop and it is doing the operation R equal to n modulo 10. That means 123 modulo 10. If you do this operation, you will get the remainder 3. Okay. Then it is written S equal to S plus R. So what is the value of S? The value of S is 0 plus the value of R, that is 3. So you will get the value 3. So the value of sum is now 3. Then we have n equal to n floor division 10. That means 123 floor division 10. So if you do this operation, see 123 divided by 10. Here 1 tens are 10, 23, 2 tens are 20. So here it is doing this integer division. So here only this value will be taken. After that you are getting this remainder. Then if you do this 30, you will get 3 tens are 30, right? So this part won't be executed. This will be truncated. Only this portion, that is our value before our decimal point, will be taken by the floor division. So you will get the answer as 12. Okay. Then again it is going back and checking whether 12 not equal to 0. Is it satisfying? Yes. Then R equal to n modulo 10. That means now n is 12. So 12 modulo 10, if you do, you will get the answer 2. Then again S is equal to S plus R. So what is the last value of S? The last value of S is 3 plus R. It is 2. So you will get the value 5. Then n equal to n floor division 10. So what is the new value of n? It is 12. 12 floor division 10. You will get the answer as 1. Then again going back, 1 not equal to 0. Is it satisfying? Yes, it is satisfying. So again doing the same operation, that is R equal to 1 modulo 10. So if the number is less than 10, then if you do the modulo operation with that number and 10, then you will get the same number as the result. That is 1 modulo 10 is 10, 2 modulo 10 is 2. If it is 5 modulo 10, it is 5. Okay, so here the remainder is 1. Then we have S is equal to S plus R, that is S is 5 and R is 1. So you will get 5 plus 1 and it is 6. Then again N equal to 1 floor division 10. See here we are doing 1 divided by 10. 0. Then it is checking with this N. 0 not equal to 0. Is it satisfying? No. So that time it comes out of the loop and it is printing sum of digits of t. Here, you know, when n becomes 0, that time only we are coming out of the loop. So we cannot write n here. N's value is changed, but t has that value 123. So 123 is S. So what is the value of S? Last value of S, it is 6. So that 6 will be printed. So this is the logic for sum of digits of a number. So let's write the next program. So our next program is write a program to find the given number is Armstrong or not. So what do you mean by Armstrong? See here, sum of cubes of the digits of a number is equal to that number. Suppose you have a number 153. Here actually we need to find the cubes of each digit first. Then you need to add it. Okay, so here we can write like this. 1 cube plus 5 cube plus 3 cube. So here 1 cube is 1, then 125, then we have 27. So if you add all these values, you will get the answer as 153. So then we need to check whether 153 equal to 153. If it is satisfying, then we can say it is an Armstrong number. So 153 is an Armstrong number. You check with any other number. If it is 123, then you may not get that, right? Like 123, it is 1 cube plus 2 cube plus 3 cube. So 1 plus 8 plus 27. Here you will get the answer as 36. So here we can say 123 is not equal to 36. So it is not an Armstrong number. See, in the last program we know how to extract the digits, right? So we know it is like n modulo 10. If you do, then you will get the digits. Then after that, in the last program we did sum of digits of a number. So we got the digit. Here we have one more operation. What is that? If you are getting a digit, that digit's cube you need to find out. So let's write the program and after that I'll explain it. So our common Armstrong number. Here as usual n equal to int input, enter the number. Okay, here also we need to use a temporary variable because at the end we are going to check the sum and the number. So here actually we are using n for our processing. So here we can give t equal to n, then as usual s equal to 0. This is for finding the sum of the digits. Okay, then in our while loop we can write while n not equal to 0. Then here first you need to extract the digit. So for that I have written r is equal to n modulo 10 in the last program. Same thing I am writing here. Then what's next? We need to find out the cube as well as the sum of the cubes. You can write in two statements, cube as one variable or you can write it together. Sum and the cube you can write in the same statement. So here I am writing s equal to s plus, then we have r cube. R cube, how can we do this? Either you can write r into r or r double star 3. We need to do the floor division, right? So how can we do that? N equal to n floor division 10. Okay, so our operation is finished here. After that what we have to do? We have to check whether the sum and the entered number are equal or not. See here entered number is n. So can we check if s equal to n? No. Why? Because here n we are using for the process. Here we have an update statement like n equal to n floor division 10. So that time the value of n is changing. So after executing this loop, the value of n will be 0. So we have a variable t here, so t stores this n. So we can write if t equal to s, then print t is an Armstrong number. Otherwise, else print T is not an Armstrong number. Okay, so let's save the program and check it. Okay, it's asking the number 153 I'm giving. So 153 is an Armstrong number. Let's check with another number. 65432. 65432 is not an Armstrong number. Let's check with a small number. Okay, 123. 123 is not an Armstrong number. So here n is 153, then t equal to 153, s is equal to 0, then 153 not equal to 0 it is checking, then r equal to n modulo 10, that is 153 modulo 10, then you will get 3, then s is equal to s plus, so the initial value of s is 0 plus r cube, that means 3 cube, 3 into 3 into 3. So here we will get 0 plus 27. So the answer is 27. Then n equal to n floor division 10. That means 153 floor division 10 you will get 15. So again we are checking with 15. So after that all these operations r will be our 5. Then s is equal to 27. Plus 5 cube, that means 27 plus 1, 25, 152 you will get. Then again n equal to 15 divided by 10 you will get 1, 1 not equal to 0. Then r equal to n modulo 10, that is 1 modulo 10 you will get 1. Then s is equal to, the last value of s is 152 plus 1 cube, that means 153. So after that it comes out of the loop and here it is checking whether t equal to s. So t we have written 153, s we got the value 153, so it's checking 153 equal to 153. So it is satisfying, so it prints 153 is an Armstrong number. So let's do the next program. So our next program is write a program to find the given number is palindrome or not. So what is palindrome? Suppose you are entering a number 121. You know, when you are reading from left to right and right to left, it is same. So then we can say it is a palindrome. That means if you have a number and after reversing that number, both the numbers are equal, that is the entered number and the reverse number are equal, then we can say it is palindrome. So in this case it is a palindrome. Suppose if you are entering a number 456, then the reverse number is 654, right? So both are not equal, so it is not palindrome. So what is the logic for doing this program? Okay, so here also we need to extract the digits, right? After extracting the digits, we need to combine it in the reverse order. That is, if you have 456, you need to extract 6, then 5 and 4. Then we need to combine it. That is, we have to make it as 654, not 6, 5 and 4. Okay. Then we have to check 456 and 654 are equal. Then we can say it is a palindrome. So let me write the program and after that I'll explain the logic. So command palindrome. Okay, here n equal to int input, enter a number. Then as usual I am assigning this one to a temporary variable. After that I am giving a variable d equal to 0. I'll explain it why I am using this one. Then as usual while n not equal to 0, then we need to extract the digit, that also you know. So I am writing r equal to n modulo 10. So now I am writing d equal to d into 10 plus r. Then I am writing n equal to n floor division 10. So let me explain the logic. See, if you have a number like 456, you know you are extracting the digit 6, 5 and 4. Then if you are writing 6, 5 and 4, it is actually not a single number. We have 3 independent digits, 6, 5 and 4. So we need to combine it as 654. Then only we can check with 456 and 654. Okay, so let's check an example. See here, if I am entering the value as 789, then t equal to, I am writing 789. Then here we have given d equal to 0. Now again coming into the loop, that is n modulo 10, that is 789 modulo 10. Is it satisfying? Yes, satisfying. So here r equal to n modulo 10, that means 789 modulo 10. What you will get? You will get the answer as 9. Then we have written d equal to d into 10 plus r. So here I told you we need to combine each digit. See, in the first operation we are getting 9. That 9 should be combined with 8. So we are starting that operation. So here actually d is 0 now. So 0 plus we have the extracted number 9. So now d equal to 9. Then n equal to n by 10. That means 789 floor division 10, you will get 78. Then again it is going back. Then 78 not equal to 0, it is checking. Is it satisfying? Yes, satisfying. Then r equal to 78 modulo 10, you will get the answer as 8. Okay. Then we have d equal to d into 10. What is the last value of d? It is 9. 9 into 10 plus 8. So now you are getting 90 plus 8, it is 98. Okay. So here this part is reversed and it is in the proper way. So for doing that operation I have written d into 10 plus r. Now we have again n equal to n by 10. So what is n here? 78. 78 floor division 10, you will get the value 7. Going back, checking 7 not equal to 0, satisfying. So r equal to 7 modulo 10, that is 7. Then d equal to 98 into 10 plus r is 7. So 980 plus 7, you will get 987. Okay, then again n equal to n by 10, that means n is equal to 7 floor division 10, you will get 0. So that time it is checking 0 not equal to 0. No, it is not satisfying. It is coming out of the loop. Then what is our next operation? We need to check the entered number and the reverse number are equal or not. We can write the line as if t equal to d. D has our reverse number, t has our entered number. Then we can say print t is palindrome, else print t is not palindrome. Okay, so let's save the program and running. Okay, I am entering the number 1221. 1221 is palindrome because it is in reverse order also 1221. So it's working properly. Let me check with another number. Okay, I am giving 1234. 1234 is not palindrome. So let's do the next program. So next program is write a program to check the given number is pi number or not. So what do you mean by pi number? Here I have given a number n equal to 1124 and here you can see 1 plus 1 plus 2 plus 4 equal to 8. That means sum of the digits equal to 8 and the product of the digits 1 into 1 into 2 into 4 equal to 8. That means sum of the digits is equal to product of the digits, then we can say it is a pi number. So how can we do this one? Okay, here also we need to extract the digits and after extraction you need to find out the sum as well as the product. After that we need to check whether sum equal to product. So let's do it. So here as usual we are inputting the value int, input, enter the number. Then I am assigning t equal to n. Then I am giving s equal to 0 to find the sum of the digits and p equal to 1 to find the product of the digit. Okay, then while n not equal to 0, then r equal to n modulo 10. Then what's next? We need to find the sum of the digits. How can we do that? S is equal to s plus r. Then we need to find the product of the digit. How can we do that? P equal to p into r. N equal to n floor division 10. Now we got the sum of the digits and the product of the digits. Now we need to check if s equal to p, then we can say print t is a pi number, else print t is not a pi number. Okay, so let's save the program and run it. Okay, I'm giving 1, 2, 3, 4. 1, 2, 3, 4 is not a SPY number. Why? So 1 plus 2 plus 3 plus 4, you will get 10. Okay, same way 1 into 2 into 3 into 4, it is 24. So 10 and 24 are not equal, so it is not a SPY number. Let's check with a SPY number. Okay, I'm giving the number 1124. Okay, 1124 is a SPY number. Let's check it. What is the sum of digits? 1 plus 1 plus 2 plus 4, 8. Then 1 into 2 into 4 are 8. Okay, so here sum of the digits is equal to product of the digits. So we can say it is a SPY number. So this is a program to find the given number is a SPY number or not. So hope you are clear with the programs we discussed today. So we already discussed some of the programs using for loop and while loop. So actually we need to do some more programs using for loop and while loop, that is nested loops. So that programs, and we need to do some exercise, that is output based questions and error finding questions using for loop and while loop. Those concepts we are going to discuss in next couple of videos. So if you have any doubts or suggestions, please feel free to comment. Thank you for watching.